listeners. I am Khemlal Janghel, a mining graduate from IIT ISM Dhanbad. In the way back 1979, in the same year I joined Tata Steel as graduate engineer and soared up to the level of head operation. In 2005, I got the opportunities in multinational companies in Nigeria. Then after I worked in multinational companies, then I retired from Rungta Mines Limited in Barbil. After retirement, again I worked in some companies, and then I joined as NIT Raipur as honorary faculty. And after 65 years of age, Rungta College of Engineering and Technology RCET, I joined in Bhilai as assistant professor in 2021, and since then I am working there in the Department of Mining Engineering. Now I am taking up the matter of transportation in open cast mines. You know, transportation means shifting of material from one place to other place. This is must because mines is away from the crusher and the processing plant. The first destination from mines to any place is there of run of mine, that is the crusher of the beneficiation plant. So it needs various transportation means. In earlier days, the track mounted haulages were quite common. Tubs were small, maybe 1 ton capacity, and the locomotives were also small. The locomotives were having the weight of around 8 tons to 35 tons, and the track gauge was hardly 600 mm, 2 feet in the past. So the mobility was not that high with that, because it used to move on the track only. Again, the common type of these are the types of haulages and the transport means shown in the chart in the different types of which is showing different types of transportation means. The track mounted was giving the rigidity of the haulage. It was difficult to extend, difficult to remove like that. So these were having the difficulties, but still in some of the smaller mines where the owners can't afford for the highly capital intensive transport means like big dumpers, 100 tonner dumpers or 20 tonners or 120 tonner dumpers and with big shovels. So the people work with manual forces, and the tubs are still loaded manually at the mining faces, and these are removed by direct haulages. If it is inclined, then endless rope haulages. If it is gently sloping, endless rope haulages are also used on the plain grounds. So, and the direct haulages systems are quite common, particularly where inclines are there. And the advantage of this system is that this is very simple in its operation. So this is very simple in its operation. One simple rope is there with the set of tubs going down and up. With double drum, there are 2 tracks parallelly going down. On one track the empty goes down, and the other track the loaded tubs come up. So that way there is a balancing of load, and then positive torque is developed, countering the weight of the loaded tubs coming up. So it is easier. That part of torque is, you can say, it is considered to be minus required on the system. So this is the types of haulages shown again. Here we come to the most common means of transportation, that is dumper shovel combination. Shovel is used for loading, dumpers are used for transportation of the material from mining phase in open cast mining. Then there are different means like conveyors. Conveyors are used particularly when even dumpers and shovel combinations are also used with surface miners. Surface miner heaps up the material on the floor of the mine. Instead of shovels, dumpers and loaders are used. Loaders are quite common because it is tire mounted, very flexible in operation. Shovels cannot be that flexible because it is track chain mounted. So apart from dumpers and shovel excavators or loader excavators, there are other combinations, that is conveyor combinations. Conveyor means it is quite common with bucket wheel excavators. The bucket wheel excavators is a continuous process for excavating the material from a mining phase, and it onward it goes on transferring the material to next conveyor systems, and then ultimately it goes to the processing plant, where the crushing and onward process goes on for refining the ore or material or coal. Last one is aerial ropeway. Aerial ropeways are used particularly in loading plants, particularly where the material comes from the mines to the bins and storage bins at the siding, where the bins are opened from bottom and the material is lastly loaded, and railway wagons rather. So, that way the aerial ropeways are quite common. Still in Dhanbad area you will see the aerial ropeways bringing material from river to mines for stowing purpose in coal mining. So, there are two types of ropeways. One is the monocable ropeway. The cable here, the cable is mounted on the roller wheels, sprocket wheels on the sides of the trestles on the height, and from on that the cable rolls over with projection of the arm rod of the buckets which are hanging from the rope. So, here the cable, the ropeway cable means the steel rope, the steel wire rope that is holding the bucket frame. At the same time it is also pulling the bucket frame. So, single cable is doing both the jobs, and it is rolling over the side roller wheels on the top. So, that is monocable. Another is carrier rope. Carrier rope means the roller of the bucket frame on the top will go on rolling over the carrier rope, and there will be another rope just below the carrier rope which will be fixed to the frame of the bucket, which will be pulling rope. So, that puller rope is pulling and the carrier rope is supporting the bucket frame from the top, and the rollers attached to the top of the bucket frame is rolling over the carrier rope. This setup forms the bi-cable ropeway. This I have already talked about direct haulage. In case of movement of the material, rope haulage, what is the prime mover? The prime mover is either electric motor or diesel engine. So, that is the prime mover. Then power of means transmission is what? End is the driven target. That means the tub is the end which is pulled by the rope. How the tub is attached to the rope? Either by direct tying with the set of tubs in case of direct rope haulage. In case of endless rope haulage, there are different clips on the rope because there is no end of the rope. So, that clips attaches the tubs to the moving rope. That way rope is the via media for transfer of power from prime mover to tubs. So, here is this is the general power transmission layout of the rope haulage. Direct rope haulage, it is very simple. It is working, even it works on the gradient of 1 in 2.5, that is 24 degrees horizontal, 1 in 10, but it is suitable for inclined gradient exceeding 1 in 10. That means it is very suitable for the steep gradients. In other words, haulage engine is slip ring and induction motor is used. Top end of the rope is obviously fixed with winding drum. That means the rope which is attached to the one end is attached to the set of wagons at the lower position on the incline, and the upper end of the rope, steel rope, is tied with the drum of the winding drum of the direct rope haulage engine, the motor or the engine installed at the top. Empty tubs go down, then and the loaded tubs come up. Rope speed is 8 to 10 kilometers per hour. There is, for safety, on the last tub of the set there is called monkey catch or the safety latch or back stay. A back stay is given on the last end of the tub. This is the plan view of the power transmission. The left side bottom is showing the electric motor. It is via coupling going to the pinion of the pinion is the small gear wheel, and the big gear wheel is the big that is shown there, that is called gear wheel, and the small gear wheel is called pinion, which is directly getting power from the motor and transferring the power to the big gear wheel. Then from after that it is coming to the winding drum, where the rope is tied with the direct set of tubs as shown. On the left side the empties are going down, and on the right side through the switches of the tracks. Switches means the one changeover like switch, railway switches. So that way the loaded tubs are coming up. As the gravity works, the advantage of direct rope haulage is, as the gravity works to lower the empty tubs, positive torque, I have already told this part, that positive torque is generated, and to pull up the loaded set of the tubs, it is not that more power consuming. Definitely it needs more positive, definitely it needs more overcoming torque, because empty tubs are going down, that is generating positive torque, but it does not mean that it does not need any power. There will be definitely pulling power required to overcome the weight of the set of tubs, loaded tubs downward. Now next comes the endless rope haulage. As the name implies, the rope haulage has got the endless rope. That means the rope at the end, both the ends of the ropes are tied or spliced and tied with each other. Splicing means it is jointed. After splicing means opening the strands and weaving it again against each other to hold the rope properly, and clamped. Clamped means that is called, the couplings are there. So that rope coupler is there, very smooth rope coupler, that is inside that the white metal is filled up, and it holds the rope nicely, and it becomes endless. So endless rope haulage, this load and empty both moves together on either on one side and other side simultaneously, because it is always moving in one direction. The rope always moves in one direction. It does not take the course of other direction to move. So the tubs from one side, empty tubs can go to the mining phase. From other side, the loaded tubs can come to the plant where the processing takes place. The run of mine means the ore which comes out of the mine after blasting by transport means to the processing plant or to the stockyard. This is the plan view of the rope haulage, schematic view. How does it work? The black set of tubs are the loaded tubs which are moving to the upper destination. The bottom side is bottom side of the diagram. You can see the empty tubs, which is not black, which is white. So that is moving together, and before the bend pulleys come, the tubs are detached after it comes to the mining place. So you can see the direction of moving. The empty tubs are going down on the right hand side, and the loaded tubs are coming up on the upper side. And on the left side of the empty tubs, you can see the diagram. The bend pulleys are there. Bend pulleys' job is to negotiate the rope smoothly over the bend. Suppose any turning comes, or any turning comes on the passage, etc. of the passage means the mine roads or the track, any bends are there. So there these type of diversion pulleys are used. On the right hand side, you can see the tension pulley. The tension is must on the rope, otherwise it will be not holding the drum, the drive drum. It will be loose. So how can the drive drum can pull the rope or release the rope? So it needs a very tight holding on the drum periphery, so that due to friction, when the drum moves, the rope is either pulled on the left hand side and right hand side, or released on the right hand side. So for giving the tension, I will show the diagram after some next slides. So two tracks are provided on either the side, as I have shown on the diagram. Entire rope length can be covered with tubs between two turnouts, pulleys, idlers, etc. Attachment, that is called turnout pulleys and idlers, or bend pulleys. Attachment and detachment of tubs can be done with the help of clips and clamps. I will show the clamps. What are the clamps? needs mild gradient to negotiate, that means 1 in 10 is suitable. Below that it works nicely, above that it does not work nicely, because above that the haulages are covered by direct rope haulage, as I have told earlier. Two types are used, over rope and under rope types. Forget about this. This is over ropes are used in underground, that is not in open cast. Return pulley is mounted on gravity take up frame. Actually, return pulley, as I had shown in the previous diagram, the right hand side pulley, that is called the return pulley, that is having the automatic tensioning arrangement, and the motor is squirrel cage motor, that is induction motor, a type of induction motor, which is a tough motor to pull the thing, to work with tougher conditions. This is the schematic diagram. The motor is on the left hand side on the top. From there again pinion to gear wheel, again from pinion again it transfers to pinion, then gear wheel, and the brake can be shown, it has been shown on the top by a diagram. It is a plan view, so I can just say top side is the brake shoe shown, and again it is transferring pinion to pulleys and drum, and see, you can see the double rope, one is going from the down, another is coming from the up. So when the drum rotates, one side is pulled, another side is released. So both moves in opposite directions, both the ropes. This is the tension pulley. You can see there is a carriage on the track, and rope is provided, rope is going around the pulley. The black color is shown, horizontal one with black thick line is the pulley. It is a section just shown from the side view, and the carriage is mounted on the track and tied with a chain. You can see the chain with the pulleys systems, and a gravity, big load is there on weights. So that weight actually the endless rope, you can see on the left side, the endless rope passes through the rim of the wheel, tension bogie on rails. Actually the whole system is tension bogie on rail. The wheel is the black color thick line, black line is the pulley. On the left, the horizontal line is the pulley. The horizontal black thick line is the pulley section. So on the groove of the pulley, it is going around the rope. Actually it is seen single, but it is having two ends. One is front, another is back. So both are covered with the same view because it is side view. So it is not that clear, but it has got two sides. Towards your face side, another is away from your face, if you view this diagram. So other side rope is coming. So that side rope is passing through the rim and going to the other side. So that way it is the, and if the tension is varying on the rope, that rope, whatever rope is written, that is the endless rope. It doesn't have any end. So the one of the side is going in one direction, other side is going in opposite direction, and whatever load comes on the rope, that is variable load, because it is catching the different sets of wagons of different weights at different times. So the load goes on varying, so that is well taken up by the gravity system. When the load is more, then the trolley is pulled towards the left side, and when the weight is less, the trolley is pulled by the weight, by gravity system on the right hand side. That is why it is automatic gravity system, tensioning system with the rope. These are the various clips. See, the rope has been shown by sectioned thick line, that is a rope, and clip is above that. You can see that on the top there is a handle, screwing and unscrewing handle, and there is a latch rod which is getting attached to the tub on the top. Upper diagram you see, and on the right hand side where the tick mark is there, just beside that there is a handle, there is screwing and screwing handle. So there are two jaws at the bottom. So that is coming closer and becoming away from each other as per the screwing and screwing method of the handle, and it is catching the rope, it is holding the rope if it is screwing in properly and if it is tightened properly with the rope. And other end of the rod, that rod, attaching rod is there on the top, that is attached to the tub, so that the whole set of tub moves with this rope is moving at the bottom. So that way, by clipping and unclipping the set of tubs can be attached and detached from the rope, moving rope, and once it is clipped, it is moving tub, when it is unclipped or it detached, then the set of wagon becomes stand still. It is given to the other side, it is pushed to the other shunting side where it is handled. Similarly, bottom clipping is there. The bottom clip is the lever. When it is lowered, the clipper, the lever is lowered, pushed down, then the jaws are becoming widened on the top. A is the widening block on the top. Right hand side you can see the section of the clip. Bottom is the rope, the hatchet portion is the rope, that is also shown. So that when the A widens the jaws, then the bottom becomes closer and it holds the rope. The other side, the J hook is already there on left side. You can see it is attached to the clip that is attached to the wagon for clipping with rope and unclipping with rope. This is another type of clip. The chain is there. Chain is attached to the set of tubs. At the bottom, it is a cam sort of cam section of the handle, which is pushed down. Then it holds the rope. When it is pulled up, then it is detached from the rope. Advantage of endless rope haulage is that less in wear and tear, because inclination is less and the load on the rope is less. So the wear and tear is less. Lesser derailments takes place because it is in a horizontal ground, and it is not that damaging because inclination is not more. It is less than 1 in 10. No peak demand of power required. That means because both sides are moving simultaneously with the loads. So the power requirement is not much, and never it demands the peak level of the power requirement. And here I must remind you again that 1 in 10 inclination means for 10 horizontal move, not the inclined portion move, horizontal move. For 10 horizontal move, 1 meter down is called 1 in 10. Okay, 1 in 15 means 15 meter horizontal moved, not along the inclination. If you are moving along the inclination, then equivalent there is a horizontal move which is lesser than the inclined movement made by you. So that portion is, the horizontal portion is 15 meter and the vertical portion is 1 meter. That is called 1 in 10. Similarly, if it is a rising ground, that means if you are moving horizontal equivalent by 10 meters or 15 meters, say 15 meters, and it is rising by 1 meter the level of the road, then it is called 1 in 15. Please remember that. Disadvantage of endless rope haulage is that it is not suitable for steep gradient. 2 tracks are required, long tracks, and endless rope haulage, making endless rope or maintaining the endless rope is difficult, because sometimes the strand comes out, you have to change the whole rope, and at the same time you have to join the rope, which takes time, splicing by splicing method. Also, due to point number 3 above, larger section of rope is required because both side tubs are there and it is handling together, same rope is handling together. So, larger section of rope is required, which is costlier, as well as handling is difficult while changing. Breakdown at any point affects the entire system. Naturally, up and down both are affected if the rope is snatched, because same rope is working on both the sides. Is a very easy thing. It is, there are 2 types of locomotives. One is the diesel, another is the, earlier time steam engine was there, but no, nowadays it is not at all. Starred marks are showing the most common type, and compressed air somewhere it is used because compressor. But again, to generate the compressed air and hydraulic power, the main prime mover requirement is either diesel engine or petrol engine or the motors or the electric motors. So, these are the prime movers always. Compressed air cannot be generated of its own. It cannot move the engine, the locomotive of its own, unless it is generated and pressure is created in the receiver. Hydraulic power is also similar thing. Unless the prime movers of diesel and petrol moves on the background to generate hydraulic pressure, it will not operate. Suitability of locomotive haulage: mild gradient, less than 1 in 15. Usually 1 in 25 is the lesser. See, if you move 25 meters horizontal for 1 meter down, going down, definitely that gradient is less, because tan theta equals to 1 by 25. So, that is definitely theta here is smaller than 1 in 15. So, more the 1 in digit is more, 15 is less, that means more gradient. more steep, and because 1 in 25 is more, 25 the denominator part is more, so tan theta will be less. So that way the gradients are measured. Track haulage layout is made permanent out of mining areas. Ventilation is good, having forget about ventilation because this is underground requirement. Reason and high haulage, wider haulage roadways is required. Haulage involves large number of mine tubs naturally because it is both side handling. Shunting and marshalling yard is required because the aerial ropeway is ending at one place. After the detachment of wagon is required, tubs is required to shunt and marshal the tubs. Now coming to the tire mounted system of dumpers. You can see the different parts of dumpers. In the front, operator's cabin is there, engine is just below that, hidden below the seat of the driver, in front of driver like other trucks. Then dump cylinders, you can see it is telescopic hydraulic cylinder which is again moved by the diesel engine of the truck, and carriage frame is there on which the scoop body of the dump body is mounted, and on the top canopy is there. That canopy, when lowest dump body gets lowered in normal position, the canopy gives protection to the cabin of the operator on the top from falling of the any boulders etc., from the bucket of the loading equipment like loaders and shovels etc. So that canopy is must on the cabin on the top of the cabin of the dumper. See the actual view of the dumper. On the left hand side you can see the operator's cabin. There is a ladder in the front through which, if the height is so much that the dumper operator cannot go of his own unless he climbs the ladder and then goes to the cabin, because the tire heights even are as big as 1.6 meter to 2 meters. The diameter of the tires is 1.6 meter to even 2.2, 2.5 meters depending upon the sizes of the dumpers. So how can he go up? So for that there is a ladder in the front, as you can see on the left side of the radiator of the engine, and back side is a scoop body. This is called a scoop body, and on the top you can see the canopy as usual, which is protecting the driver's operator's cabin in the front from fall of any boulder etc. That is made of very strong steel sheet which prevents the boulder if it is falling from the top while loading the dumper. If this is just tipper truck, it is ordinary truck with the jack to lift the body. Its body is not a scoop. This is the scoop body. Scoop means it is like a spoon. The bottom portion is going and thinning out when it is going to the back. In the case of tippers, you can see the depth of the body is all along same, and this is the rectangular body. This is not the scoop body. Okay. The transport system, when dumpers are moving, because of tire movements on the roads, lot many dusts are generated, as well as the diesel engines are running in so many pieces. Separate dumpers are, all separate dumpers are having separate engines. So the total diesel generated out of these all dumpers, because in an open cast mining, the normal number of dumpers are varying from 8 to 15 dumpers at a time, and that too moving so frequently on the roads. So it is spreading diesel smokes as well as diesel engine smokes as well as the dusts, and whereas in case of this conveyor system, it is not the pollution to that extent, and pollutions only at the drop points of the conveyor system where the materials are received by other bed. That too it can be covered properly for no dust generations or minimum dust generations. It is most suitable for long and hilly terrains. It can negotiate well because it is not asking for a big wide road, and the damage to the road so far environment is concerned by cutting the trees etc. It can be maintained easily also. Rather the faults are happening at particular point which can be maintained. It is weatherproof system, but only thing is that if the conveyor system is down, it paralyzes the whole system, whereas in case of dumpers, at least 1-2 dumpers are down, rest other 6 dumpers will be running, 7 dumpers will be running, it will be not parallelizing the whole production, but in this case definitely it is. Disadvantage of conveyor, definitely I said that one belt is down means that it is parallelizing the whole system. We need to have another parallel belt where it is urgency to maintain the production, or we should have the surge piles. Surge pile means stock piles which we buffer stocks before the plant, I mean to say at the plant, where if any conveyor the single conveyor from mines to plant gets down, it will be not parallelizing the whole production. The production can be fed from the stock, the reserve stock kept at the starting point of the processing plant. Then jamming of chutes and other things takes place very frequently. It needs clearing, etc. time to time. These are the problems. Then it is very vulnerable to fire because it is rubber system, rubber belts. It can catch fire and it will be difficult to extinguish the fire when it catches because it spreads very fast, and it cannot carry the material, bigger material like dumpers carry, like because dumpers can carry the big boulders etc. from mining phase, but the belt cannot carry it. For this the material has to be below 500 mm in size, but its biggest advantage is that it is a continuous system. It gives very large output, particularly with bucket wheel system, bucket wheel excavator system. It is a must, it cannot be avoided. It is the integral part of the bucket wheel system, bucket wheel excavator system from the mining phase, as it is in Neyveli Lignite Corporation. This is wheel scraper. You can see the cabin is in the front, and at the mid there is a bucket which opens at the bottom through hydraulic jack system. You can see the plan view of that. Swiveling there is there. It is having the lesser turning radius. Swiveling, the right side is the body, the scoop body, left side is the cabin of the operator with engine etc. And you can see the swiveling at the mid where the point is there, and the bottom portion you can see where scoop bucket is there. You can see there is at the bottom there is written scraper bucket. After that, bucket lowering cylinder is there. So bucket lowering cylinder means the edge of the bucket is lowered, right hand side remains fixed with the frame, the bottom side, the left hand side comes down, opening the sharp edged blade opening door which digs into the ground when it is opened at the bottom, and the scraper is moved ahead scraping the softer ground. It is used for clayey material and the soft soil etc., particularly for farmland. If you want to remove the soil etc., it removes the material and cuts the material and fills the bucket simultaneously. Then it is closed by the cylinder, bucket lowering cylinder, it is closed, and the material is carried to at least 1 kilometer distance or 2 kilometers distance to the dump yard. There again the bucket is opened at the bottom to spread out the material, and then after emptying the bucket it again comes back. So it is one of the means of transporting, cutting and transporting the material. It does not need any excavator or anything. So this is the advantage of this wheel scraper. Thanks to all of you.